I've been reading books of old, the legends and the myths, Achilles and his gold, Hercules and his gifts, Spider-Man's control, and Batman with his fist. And clearly I don't see myself upon that list. But she said, where'd you wanna go? How much you wanna risk? I'm not looking for somebody with some superhuman gifts, some superhero, some fairy tale bliss. Just something I can turn to, somebody I can kiss. I want something just like this. Oh, I want something just like this. testaments they told, the moon and its eclipse, and Superman unrolls a suit before he lived. But I'm not the kind of person that it fits. She said, where'd you wanna go? How much you wanna risk? I'm not looking for somebody with some superhuman gifts, some superhero, some fairy tale bliss. Just something I can turn to, somebody I can miss. I want something just like this. I want something just like this. Oh, I want something just like this. Where'd you wanna go? How much you wanna risk? I'm not looking for somebody with some superhuman gifts, some superhero, some fairy tale bliss. Just something I can turn to, somebody I can kiss. I want something just like this. I've been reading books of old, the legends and the myths, Achilles and his gold, Hercules and his gifts, and Spider-Man's control, and Batman with his fist. And clearly I don't see myself upon that list. But she said, where'd you wanna go? How much you wanna risk? I'm not looking for somebody with some superhuman gifts, some superhero, some fairy tale bliss. Just something I can turn to, somebody I can kiss. I want something just like this. Oh, I want something just like this. and the myths, the testaments they told, the moon and its eclipse, and Superman unrolls a suit before he lived. But I'm not the kind of person that it fits. She said, where'd you wanna go? How much you wanna risk? I'm not looking for somebody with some superhuman gifts, some superhero, some fairy tale bliss. Just something I can turn to, somebody I can miss. I want something just like this. Where'd you wanna go? How much you wanna risk? I'm not looking for somebody with some superhuman gifts, some superhero, some fairy tale bliss. Just something I can turn to, somebody I can kiss. I want something just like this.
Ladies and gentlemen, good afternoon. Welcome to the 2017 COMPUTEX Forum on Artificial Intelligence. This afternoon's program will begin in about 5 minutes. Please be seated. 在场的各位贵宾、各位媒体朋友们，我们今天下午的议程将要在5分钟后准时开始。再次提醒您，我们下午的议程将要在5分钟后准时开始。我们请在场的所有贵宾、所有媒体朋友们能够尽速的入席就座，谢谢。 Ladies and gentlemen, good afternoon. Welcome to the 2017 CPX Conference on Artificial Intelligence. This afternoon's program features speakers from industry-leading corporations such as IBM, DBS Taiwan, NVIDIA, Quanta Computer, Intel, and Appier. To kickstart this afternoon's program, I would like to invite the host of this conference, Mr. Walter Ye, President and CEO of Tetra, to deliver his welcoming remarks. Ladies and gentlemen, let us put our hands together and give a very warm welcome to Mr. Walter Ye.
Honorable speakers, James Huang, Chairman of Tetra, Simon Huang, Vice President of Tetra, distinguished guests, ladies and gentlemen, good afternoon. On behalf of Tetra, I would like to welcome all of you to join this afternoon's section on artificial intelligence. We are grateful for the industry leaders for your support to this event. Artificial intelligence has been a hot topic recently, and AI companies are sprouting up all over, and the market is flourishing. There is a significant increase in investment and adoption in AI by enterprises. And according to CB Insight, there are more than 1,000 startups related to AI algorithm around the world, and over 200 of them have been acquired since 2012. Artificial intelligence today includes a variety of technology and tools such as natural language generation, speech recognition, virtual agent, deep learning platforms, and more. It is believed that AI holds a lot of possibilities, opportunities, and abilities to improve the human experience. Maybe next year, robot will open for this session, not me. And Tetra organized COMPUTEX this year, and also the forum and keynotes. The topic is from mobility to intelligence. And COMPUTEX this year, we have 1,600 participants from all over the world. And we are expecting to have 40,000 visitors from international. And the highlights this year is AI. So this afternoon's AI forum is a very important part of COMPUTEX. And also, we have startup. So tomorrow morning, we have startup session. And we'll come back tomorrow morning. And of course, we have Innovex. We invite 272 startups from all over the world to join our COMPUTEX Innovex. So please take your time to visit our Innovex for startups from Taiwan and also from other countries, like from Israel, from Holland, from France, from USA, from Korea, and other countries. It is a very important part of COMPUTEX, and it is our aim to transform our COMPUTEX to building global technology ecosystem. So we transform from product exhibition to IoT application and also business solution. And echoing the industry trends, today's CPX conference is honored to have invited 4 keynote speakers from companies with big names in the field of AI. To raise the curtain of today's keynote, Mr. Jeffrey Roda, General Manager of Great China Group of IBM, a true leader in the field of AI. He is in charge of the business in Asia Pacific and now in Great China region. And he will talk about connective in the cloud era with Mr. Spencer Wang from DBS Bank. Next, Mr. Mark Hamilton, VP from NVIDIA, the pioneer in AI. He is from California, and he will share the stage with Mr. Mike Yang from Guangda Computer to explore deep learning. Further, Mr. Peter Chen from Intel, the proven leader in silicon innovation, will cover how the coming flood of data will be next computing challenge and end-to-end solutions that span from the data center to the edge. Last but not the least, Mr. Chi Han Yu, CEO and co-founder of Appear, the eye-catching Taiwanese startup, will talk about how they put AI into action. All these industry leaders in the era of AI will share their unique perspectives on such topics. I believe the insights of our speakers will be very beneficial to all of us. Before I give the floor to Jeffrey Roda, I wish all of you have an informative afternoon. And thank you again for all the speakers for your great contribution to the COMPUTEX. And also I would like to, on behalf of Tetra, thank all the participants for your support to COMPUTEX. Thank you very much. Thank you.
Thank you, Walter, for joining us. 我们接下来要进行的是我们今天下午的贵宾合影留念的时间。我们首先呢，再次的请秘书长，我们请您再次的上台。那我们接下来邀请到的是我们的 James Huang, Chairman of Tetra. We would like to invite our 2 representatives from Tetra to join the photo call. In addition, we would also like to invite all the keynote speakers in the afternoon to please go on stage for a group photo shooting. Ladies and gentlemen, please welcome Jeffrey Roda, General Manager, Greater China Group, IBM Corporation. Spencer Wang, Head of Technology, DBS Taiwan. Mark Hamilton, Vice President, Solution Architecture and Engineering, NVIDIA. Mike Yang, General Manager and Vice President, Quanta Computer. Peter Pauli Chen, General Manager, Products and Technology, Data Center Sales Group, Intel. Chi Han Yu, CEO and co-founder of Appear. We would like to thank James Huang and Walter Ye for joining us in the afternoon. We would also like to thank the 6 speakers who have traveled great distances to join us this afternoon. So, gentlemen, please put your thumbs up. 我们请台上的贵宾举起您的大拇指，为我们今天的活动加个油，也按一个赞。Thank you for joining us today. Thank you, and you may now return to your seat. 我们请台上的贵宾先行回座。And now is the moment we've all been looking forward to, the keynote sessions. There will be 4 keynote presentations in the afternoon, and each one of them will be about 40 minutes long. The first speaker of the conference will be Jeffrey Roda. Jeffrey had spent more than 30 years in the technology industry with IBM in areas including sales, marketing, channels, and IBM.com. He's currently the general manager of Greater China Group, IBM Corporation. Jeffrey's co-speaker, Spencer Wang, head of technology, DBS Taiwan, will join Jeffrey on stage in a few minutes. I will now turn the program over to Jeffrey.
谢谢你，台湾人，午安。Yeah, so I have a little Mandarin, but that was a new one for me. For everyone else, good afternoon. It's an honor to be here today. Thank you for the invitation. Really appreciate it, but really also with my fellow speakers. So I think you'll hear many different points of view. And one thing I have learned, speaking on this topic and several others, is that in a room like this, there's a lot of experts in the room. And many of you could come up and tell a story and give a point of view that would also be quite interesting to everyone, including myself. So between Spencer and I, we're going to take about 15 minutes each. I'm going to deliver sort of a point of view on AI, and then he's going to give a real-world example of what's happening at DBS on digitization. If you can take away one or two ideas, Spencer and I will say victory, declare success. All right, so let's get underway here. So we just passed the 20th anniversary of, for those of you old enough to remember, of IBM's Deep Blue supercomputer, right, at the time, beat the world chess champion, which was the first time that ever happened. Complicated game, but this was 20 years ago, right? So then, since then, we've moved on, and about 6 years ago, we played the US game of Jeopardy. So those of you who don't know that game, it's a quiz show, but it's not funny, it's intellectual. They provide the answer, and the contestant provides the question. And what they do is they play with words, double meanings of words, rhyming words, make it very difficult to really get what the clue is or what the answer is. So Watson, at the time, was really only using one API. It was the Q&A API. And it had 200 million pages of structured and unstructured text. For instance, the whole entirety of Wikipedia was consumed by Watson at the time. And again, beat the two top champions at this game show, and that was 6 years ago. Now, between chess and the game show was a little more difficult because board games have rules, right? I think it's 64 spaces, 32 pieces, which one can do what, and you can sort of structure the rules. But the game show really got into a little bit of language and understanding in relation to what the answer was so they could give the question. Big change. One of the things we did learn there, by the way, that there's a piece where humans do something really well, and AI systems do things very well. And that combination, I think, is where there's going to be some great value. And I'll get into some of that here in a second. First of all, relevance to Taiwan. Wow. For those, most of you are from Taiwan, but for those of you who may be here for the first time, what a place, right? As far as importance in the electronics industry, for instance. This is a place of innovation. So when you think about things like IoT, which is earlier in the session, and now we're into AI, you can bet Taiwan is going to be a place where a lot of innovation happens. Truly a hub of the electronics ecosystem. Okay, now, I really do think, and IBM also has this point of view, that we're at a critical time in business. Business strategy is almost, not quite, because it isn't entirely technology, but it's almost equal to the technology strategy. I mean, there are businesses that are just pure tech, but almost every business now is a technology business. Everybody's hiring data scientists, right? You're going to hear from DBS. Could you think of a business that was less 20, 30 years ago technology-oriented than maybe that sector? But now they're way out in front, right? And a lot of disruption there. And I would tell you, for those of you who were not born on the web and are worried about disruption, it's time to go on offense, right? Don't wait for the disruption. Don't worry about who's coming, because they're coming from outside your industry. Time to go on offense. And that might mean eating into a little bit of your current business. It might mean that, but if you're not, somebody else is, right? So we're making decisions today, you are, and my company as well, for running our business. We're making decisions today that are going to affect us for decades, architectural decisions around AI, cloud, and data. And it's almost hard to talk about one of those without talking about all three, right? I laughingly say 3 sides of the same coin if you count the edge of the coin, right? It's almost impossible to talk about one because really AI and the data is going to be in the cloud, it's going to be on-prem. AI is going to be delivered either machine learning on premises, you might do it outsourced, but you certainly will get AI through the cloud at some point from one of your providers. So this is going to be something that impacts your business for a long, long time, so we need to get it right. So what do you need, right? Data. So where's the data, right? What did the customer buy in the past? It's in your data. Who are they loyal to? What companies? It's in the data. Weather, in the data. Social media, news, it's all in the data, right? It's all in the data. And to top it off, where is the data? This is why I think we're at an inflection point. 20% of the data is searchable on the web today. 20%. Not 80, not 90, 20. The other 80% is in your hands. It's in your systems. It's your inventory systems. It's your loyalty card systems. It could be weather. It could be your data on somebody else's cloud, like a Salesforce.com CRM cloud. It could be your CRM data, but on their cloud, but it's yours, right? And I'll tell you, one of the things I would be very concerned about, and the decision that we all have to think about, is how do we play in this new AI, because it's going to be through the cloud. Do you give your data to a common knowledge graph to be used by other users that come to it? You're the 80%. You've got the family jewels, right? You've got the money. Do you provide that to a cloud or an AI system that's going to create a common knowledge graph for the next user to come in and get insights from your data, right? Maybe not. But it's a decision we're going to make, and it's going to impact us in the future. So your data has tremendous value. The other thing that comes with the data that you need to think about when it comes to AI is for instance, you don't ask your doctor for real estate advice. Domain expertise and domain experience is very, very valuable when it comes to AI. Some of it will be public. Some of it that the AI will provide some of that, and some will be your data, and some will be data you acquire, right? Some will be public, like you can pay for weather data, for instance. Some will be web data. Some will be social media data that maybe you acquire from a social media provider. But nevertheless, it has tremendous value, and it's not just a speech to text on the front of a search engine, right? Which, by the way, very valuable. The day's coming, some of you already do this, but the day's coming when we'll all that'll be our interface. And if you think you're tired of hearing people on the phone, on the plane saying, yeah, we just landed, right? Now it's going to be people doing emails by voice, they're going to be doing web searches by voice, and it's going to be, oh my goodness, right? So we'll wait to see how that works out in social life with all of us, right? So your AI needs to understand domain, needs to understand industry. How industries work is very important. You're going to hear from DBS. That's a whole different conversation than healthcare and manufacturing, which I'll show you here before I ask Spencer to come up. So industry expertise is actually very critical. Now, Watson, Watson is IBM's cognitive system. That's our AI play. It can read and understand social data, weather data, enterprise, consumer, traffic. It can see and read. It can understand sounds, obviously. But it can read photographs, it can read images better than we can, right? Especially in medicine, spotting things on a medical chart or something that is something that humans can't see. So in fact, we've got a big play in healthcare, which I'll explain here in a second. But the possibilities are almost endless. Speaks 12 languages. But one thing we get a lot is, will it replace humans? And we really feel that artificial intelligence will augment human intelligence, augment what we do, right? It'll make your call center people better. It'll provide recommendations to a doctor for the doctor to make a diagnosis. not necessarily replacing people, but augmenting them, providing them a scale of information and an understanding of that information that we can't do, we can't possibly do. Strong governance is a big deal. There are 4, 5, 6 companies that were the founding companies of this initiative, and they're all names in AI that you know, but now there's dozens. And it's not just companies. It's organizations around human rights, organizations around privacy. So this is going to be all about helping society understand where AI is going, what are the sort of, not rules of the road, but sort of the vision of where AI can impact society, right? Transparency will be very key. Now, use cases, and let's start off with healthcare. Healthcare information doubles every 73 days. It's impossible for anyone to understand and grasp all the medical journals, clinical trials, magazine, journal articles, et cetera, new drugs, all that sort of thing. Obviously, Watson can, so an AI system can do that. We've worked with Memorial Sloan Kettering since 2012, and really ingesting huge amounts of information around things like cancer, and I'll show you a couple examples here. Cancer, clinical trials, genomics. It can take your, recommend possible treatment for cancer patients, takes genomic profile information to recommend clinical trials. But again, most important, and the way Watson works, is it provides a recommendation, actually a few, ranked. It provides a percentage of confidence in those recommendations, 90%, 80%, 95%. And then it provides the documentation, the evidence of how it came up with that recommendation. That's presented to the doctor, and the doctor, with their knowledge and their experience, with that in their pocket, does the diagnosis, right? So Watson's not doing diagnosis, but it is providing that doctor with a much better understanding of what the art of the possible is in developing the diagnosis. Now, let's take a look at manufacturing. An industry, again, with IoT, I don't know how many went to the IoT session, but IoT and AI are going to, that's another one that's almost one conversation at some point. Let's take a look.
Things are changing. They're more than objects and tools. They've become experiences that enhance your life. Whether there's something personal or something you work with. That's why the world's leading companies are transforming the way they bring products to market. When cognitive manufacturing meets Industry 4.0, insights from all kinds of data help improve reliability, enhance quality, and support your workforce. Designers can make changes based on how products are used. Factories and workers can customize products at an unprecedented scale, and finished products can evaluate their own performance, learning and improving continuously. IBM Watson IoT is helping companies connect everything, from personal appliances to manufacturing equipment to bridges. So now everything can feel less like a thing and more like an essential part of your life.
Very good. So as you can see, it affects a lot of different industries. What I'd like to do now, Spencer, is come on up. Spencer Wang, again, head of technology for DBS here in Taiwan. And I've talked about healthcare, a little touch on manufacturing, but we're going to hear a real life story of what's happening in the banking industry. So let me turn that over to you.
Thank you, Jeff.
Thanks.
Good afternoon. I'm Spencer Wang. I'm the head of technology of DBS. Well, first of all, I think I need to give you some introduction of my company. Probably not so many people in this room knows DBS, right? Okay, actually DBS is a bank based in Singapore. We are the largest bank in Singapore, and we only focus in Asia market. So there are 6 marketplaces we are focusing in Asia. Even we are targeting ourselves as the best bank in Asia. However, last year, we won an award called the World's Best Digital Bank from Euromoney. It's very amazing that Asia-based bank win a prize, a big prize from a European community. Okay, why we got this award? Okay, that's what I'm going to talk about today. how we do the digitalization and how we make use of the artificial intelligence. Okay, actually, this is our CEO. He make a brief introduction why we won this award. Actually, we are a very technology-oriented bank. Actually, we embrace technology very large, okay? And we believe that the bank today will not be the same as the bank tomorrow, okay? So we are going to use the technology, no matter it's cloud, artificial intelligence, and most importantly, we need to embed the digital DNA into every step of DBS. Okay, so that's the reason why we won this big award. Okay, I'll show you this chart. Probably people read this book before. This in the human history, the first time that technology evolving so fast, okay, that people cannot adapt. As you can see, we are here right now, right? Technology is moving too fast. We are here. It's not easy for us to adapt it. So like when we think about the old day, the television, the telephone is quite easy, right? Just turn it on, turn it off. But now there are so many technology in the market, and people just confuse how we can make use of it. This reminds me a story. When I just joined the bank 2 years ago, and one of our friends asked, what are you doing in DBS? I told him that I'm going to be the head of technology. And he said, what it is? What actually are you doing? Then I say, in your common word, it's the CIO. Oh, okay, the career is over. So why say so? Why the CIO's position is career is over? Because there are so many technology, there are so many things you need to adapt, especially in a bank. It's a well-controlled environment. How can you make use of a technology to make your operation smoothly? Okay, that's my idea why the DBS think that the artificial intelligence is important in this region, or digitalization is important, because we need to make use of technology to learn the technology and make our operation more smooth, more efficiently. Okay, so actually, we just talked about tomorrow we're going to be a startup session. Actually, start from now, it's a startup session right now. Our CEO treats us as a 20,000 startup company. 20,000 is our number of our employees. Okay, we are back to 3 years ago, our CEO told us that we should not act like a bank anymore. We should treat ourselves as a startup company. Okay, so we start our transformation 3 years ago. Okay, so we need to build up the startup culture. We need to think about what is startup, what's the good thing of startup, what's the challenge of startup, right? So that's why I'm trying to say a couple minutes ago, we need to embed the digitalization DNA into every step of DBS. So the first thing we do is we rearrange the space, right? We change the space and we make the space more friendly and more human-oriented. So we have a dedicated space, we call it joyful space. So people come to work, feel like, okay, this is a good place to work. And we also partner with a lot of industry partners. We don't think that those fintech is our enemy. Okay, a lot of banks think fintech is a threat, but we don't think so. We think they are our partner. We can share a lot of things to them, and we also can learn a lot of things from them. Okay, so for example, fintech they can move things very fast, right? We need to think about how they can move the things so fast. But they will fail pretty easily, right? So the bank can help them how to, fail earlier so that they can learn from the failure, okay? And we also have a DBS hotspot, which is like an incubation center. We're helping those startup companies to come to this hotspot and to leverage our banking environment to learn or to make use of the technology. If that's a good thing, then probably we will harvest into our services. Okay, so actually, I don't know whether you know that DBS is the first bank in Asia who run a hackathon in Asia. And actually, this year, we also launched the Hack to Hire in India and Singapore. Say the winner of the hackathon, they're going to be hired by DBS. Okay, so there are a lot of new ideas that we are trying to partnership with fintech and also like partner like IBM. And we also do make use of a lot of tools, new tools introduced by IBM, by a lot of partners, right? And we do the experimental, like in the past 3 years, we do over 1,000 experiments. See how this work, internal process or new product or technology. So, and we also, in our technology point of view, we need to build everything in cloud. So every system, if it's not cloud ready, you need to get my CEO's approval. Okay, it's different, that's different. So that we need to make our system more moving to cloud, and so that we can act faster for those rapid markets. And as I said, that we need to enforce our task force, right, to make them digitalized, right? So we have to have them immersion them to have them to enable them to learn new skills, especially for the digital world. So one of the KPI in my staff or my team, they need to learn one new skill this year. Okay, no matter it's data, it's high performance computing, or as long as it's good to DBS. So I told them you cannot just learn, say you learn COMPUTEX and say this is a new skill. No, this is not good for the bank. But if you say that if you can learn how to cook a COMPUTEX and help our customer, help the bank to create revenue, then that will be a new skill. Okay, so that's one of my KPI this year. So we are trying to help our people to know that digital is the most important DNA. And if you, I'm sorry I cannot show our intranet to you because it's internal. Actually, if you see DBS intranet, you will see it's just like a normal technology company. You'll see a lot of digital classes. If you want to learn Python, you want to learn R, you want to learn artificial intelligence, what's the impact to the financial market, you will see those lessons in our intranet. And also, we have this lesson available in our mobile phone. So we were trying to make our people, and also, every staff, including the staff in the branch, they need to attend 9 hours of training. So that by any means, we encourage people to learn to adapt the new technology so that they can survive in this fast-growing industry. Okay, so we have a lot of digital initiatives, like we have new system, new applications. By the way, the reason why we want this, the world's best digital bank is not because we launched a powerful killing application. No, we didn't launch any killing application, but we did have some initiative. But those initiatives do a lot of ecosystem integration. Like we integrate with partners like IBM, like Microsoft, like some Google, those industry giants, and also the fintech companies. We also, whenever we do any business model, we need to think about this, whether this is data-driven or not. Can we collect more valuable data from this new business, so that we can, from the very beginning, we develop that business, we start thinking about how we collect the data. Okay, and of course, we are a bank. We are a wealth management organization, so we need to comply the regulation, so that we need to make sure everything complies to the regulators' requirements. So, give an example. Even starting from this year, we are doing a lot of, process automation. That's part of the artificial intelligence in these four dimensions. One of examples is in our internal audit. You will never imagine that the internal audit will do the process automation. They usually just use their human eyes to check, do you do this, do this or do that? But actually, we're starting to do the process automation, a little robot, the process robot inside our system to check whether you comply or not. And they will generate a report to the audit, so that they can save a lot of effort by the user and also the auditors. Okay, that's one of the typical examples of how bank to utilize this artificial intelligence. And we work with IBM, actually have launched a lot of services. 3 years ago, I think we worked with IBM for the Watson. At that time, Watson still not in the cloud. We built a Watson in DBS headquarters, and we're trying to analyze our VIP customer portfolio and give them some important financial advices. And last year, we worked with IBM to study process automation. As I said, the audit process automation is just one of example. Actually, there are a lot of operation automation is in place. So we have the vision that everything, every system we design, or every business design, we should design for no ops. If you are not in the banking industry, you will never know how many effort for our operation people did. When you apply the credit card, you don't know how many people helping you to do the data entry. Okay, actually, there's a lot of effort for banks to do the operation. So we are trying to do, but implement the process automation for those operations. So that's typical example. And this year, actually, we're going to launch it very soon. But I cannot tell the detail. But actually, we're going to work with IBM for some intelligent conversation stuff, right? Which is going to launch to market probably the third quarter. Okay, so these are the base of when we're doing this digitalization. Artificial intelligence are the foundation of all of those initiatives. Okay, this is just one of the solution map of what IBM offered to us, right? So I won't talk much about this, but actually it's make use of Watson. Oh, okay, let me put it this way. When we try to launch this, or we're trying to pick up a vendor, actually there are 5 to 6 vendors, if I remember correctly, come to DBS and present their solution, say, okay, this is what we can do. And at the end, IBM got a business. But it's not me to pick up the solution, it's the user to pick up the solution. And I ask the user, why you pick up IBM? Okay, and one of the reasons is they believe that IBM is quite professional because the way they present is more understand our language. Second is they feel that when they do the play around, they found that the Watson can really understand what we are asking and give the reasonable answers instead of just question answer, but sometimes the answer just don't know and they just ask me to go to someone for help. So Watson can really do the reasoning. So it's the more major reason why the user pick up this solution. So we actually, well, hopefully we can work with IBM to launch this to market, successfully. Okay, this year. Okay, finally, if you can tell, this is our working space. This is not a lounge. This is not a pub. This is DBS office. Okay, every floor in our headquarters we have this kind of space, which is we call it social hub. So every employee can share or have a meeting with people, colleagues or outsiders in this kind of facility, so that people feel that they love to work in this environment and make it more agile. You can work everywhere, you can have meeting everywhere. Okay, so let's conclude my presentation so that I hand back my time to Jeff.
Stay here.
Okay.
So I like the quick hitting format. So we expect Watson is going to be delivered really through APIs. So it's going to show up in places you don't know. It's not going to say Watson. It's going to be an application like DBS and what they're doing. We expect Watson to touch 1 billion people this year. So you already know, you're going to hear from other speakers that this whole AI thing is real. It's happening. It's not tomorrow. People are doing it today. And successfully so. So on behalf of Spencer and I, thanks for your time. 谢谢你们.
Thank you.
Thank you.
Jeff.
Let's walk this way.
We would like to thank Jeffrey Rhoda and Spencer Wang once again for their excellent presentation. And the next speaker will be Mark Hamilton, Vice President, Solution Architecture and Engineering, NVIDIA. At NVIDIA, Mark leads the worldwide solutions architecture and engineering team responsible for working with NVIDIA's customers and partners to deliver end-to-end solutions for artificial intelligence and deep learning, professional visualization, and high-performance computing. Mark's co-speaker, Mike Young, General Manager and Vice President of Quanta Computer, will be joining him here in a few minutes. And Mark would like to start his presentation with a short video. Ladies and gentlemen, please welcome Mark Hamilton.
So thank you everyone for inviting NVIDIA to speak in quantum computing technologies. That video was a brief introduction of what I'm going to talk about. So everyone else who is interested in the details can leave now. But COMPUTEX is a computing show at its core, computing technology. And NVIDIA today has been called the AI computing company. And the DGX station and DGX that you saw is some of the core of the computing part that we do. But also, it's all of NVIDIA software. We have over 10,000 engineers at NVIDIA, and more than half of them actually work on software. But as the chairman of COMPUTEX sort of said it at the start, COMPUTEX is a special show for many reasons. To NVIDIA, it's a special show. And I attend a lot of trade shows, but our co-founder and our CEO, Jensen Huang, was born right here in Taiwan. So it's always a very special show because our CEO is always here, and it's one of his favorite conferences. But COMPUTEX is not just about the hardware or the software or the computing. It's about the relationships. Right? I heard that over 1,500 exhibitors are here today. And actually, I'll tell you a little story. I'll maybe embarrass Mike, my co-speaker. And he's looking up because we didn't rehearse this. But it was 2 years ago, right here at COMPUTEX, over in the 3rd floor of the Grand Hyatt across the street, that Jensen Huang and Mike and myself and some of the other QCT and NVIDIA engineers got together and we said, AI is really going to be bigger, right, than it is today. And we said, we want to, in the future years, be able to talk about technology, being able to deliver the technology for AI computing. And in fact, it was at that meeting that we hatched the design and came up with the designs of what we announced this week, which was the NVIDIA HGX platform for AI computing in the cloud. So the AI computing company, right? What does a company that started doing computer graphics, how do we end up doing AI computing? But if you think about it, it's natural, right? Computer graphics is all about taking real life that sits inside a computer, a representation of life inside a computer, and turning that into something you can see and hear on the screen. And so much of AI is doing the opposite of that, right? Observing real life through data, through images, through voice, and turning it into something that the computer, that Watson APIs, the DGX station can understand and reason about. Now, we are a technology company, so I have to talk a little bit about the technology. For the history of COMPUTEX, right? Most of the people that came here to talk about software, their software developers were writing the same sort of code that since the history of software people have written. If, then, else code, right? If this happens, then do this, otherwise do something else. And the problem is, with all the big data that's been collected over the last 10 years in the cloud. Think of all those, I don't know how many textbooks or pages Watson knows. The problem is, even with all the great software developers at IBM, and they have tens of thousands, if not more, software developers, IBM doesn't have enough software developers to write enough if-then-else code. Google doesn't have enough software developers to write enough if-then-else code. And what AI does in this modern use of AI is it takes images and the software is writing software. By all the data that you're feeding in to Watson or the other AI software programs, there's a learning algorithm that goes through and programs what's called a deep neural network, hence the term deep learning. And then you pick up that network, that trained model, and you embed it in an API, in a self-driving car, in a drone, or in another intelligent device. Now, I think because all of you are here, I don't have to tell you about the rise of AI and how popular it's become. But why the GPU, right? Why is a special purpose processor necessary? And it's because of this very famous law that has driven exhibitors at COMPUTEX for more than 40 years. And that was Moore's law that said performance sort of doubled every 18 months. For much of the last 40 years, that was true. Now, Moore's law is not ending, right? Great technology, great fab companies, TSMC, great semiconductor companies, Intel, right, continue to make faster and faster transistors. But those transistors are only getting faster at about 1.1% a year. This is not an NVIDIA study. This was put together by some great researchers. Dr. Hennessy, the president of Stanford University, and others collected this data. Now in the green, we've graphed the performance of the GPU, 1.5x a year. And so the question comes up, right? How does NVIDIA take the same transistors that anyone else buys, right, designed by the same graduate students that any other company can hire, and deliver 1.5x performance? So some of that we'll talk about today. GTC, well, this is probably Jensen Huang's second favorite conference. The first is the GPU Technology Conference, our company's conference. And again, you can see the rise in the attendance there, the number of GPU developers, and CUDA, our programming language for the GPU, have all seen tremendous growth. And certainly over the last 5 years, much of this has been due to artificial intelligence. Now, you know, Jeff said, AI is here today, right? And even if you don't know it, I'm sure all of you use on a daily basis services that are powered by AI. And there's a Microsoft event going on right next door. If you use Cortana built into Windows 10 or your phone, if you use Google Now, if you use Baidu, if you use Siri, all of those systems are trained. The deep neural networks that on your phone recognize what you're saying are trained by GPUs. And in fact, if you say, well, yeah, but you know, I'm not ready to use that, it's not accurate enough. In simple image classification tasks, and even in voice classification tasks, the best neural networks today are superhuman, are better than a human. Now, it's great to talk about apps on your cell phone, right? But my daughter actually is becoming a pediatrician, graduating on Friday. So I'm actually leaving COMPUTEX tomorrow night to get back to the US. Have to go to her graduation. But she wants to be a pediatrician, right? And she's going to be that pediatrician that was in the IBM ad. It was actually a very realistic ad because I don't know why the pediatricians always love to wear, in the US they're called crocodile shoes, but they're these, you know, they're very comfortable shoes to wear. But anyhow, you know, she tells me, right, when she started school, even 4 years ago, they were still having to memorize so much stuff. And by the time she graduated this year, they don't have to memorize so much stuff. They still have to memorize a lot, but they know, she knows as a pediatrician working in the emergency room in the hospital, she will have deep learning based systems that provide her so much more information that she could ever go in and keep track of by herself. And speaking of Microsoft, a great example there by a Microsoft engineer who was blind, right? And think about it, in day-to-day business, just think about if you were blind, right? Think of going to a meeting, right? Think of if you're talking here. I could be blind and talking right here, but I know, Eunice in the front row is paying attention and nodding, right? And there's actually, usually when I'm in a presentation, there's someone not paying attention and I can call them out. But everyone seems to be paying attention here, right? But if you're in a business meeting, think about what you can't tell, right? Oh, the person across the table looks really bored or looks really angry. So this engineer at Microsoft used Microsoft's cognitive services running in the cloud and built an application that sits on his phone or on his eyeglasses, and it's connected to his phone and in the cloud, right? And runs AI and tells him what he's actually not seeing. And it's not just in medical or in consumer, but today, right, over 1,200 startups are in NVIDIA's AI startup program, right? And so I don't think every AI startup in the world is in our program, so I think 1,200 is a low number. Assistants, right? This is one. I didn't know that EVA Air had one. I flew out on EVA and flying back, so I'll have to go in and try to find the EVA, but this is one that Hilton Hotels has. Every day it seems, every week, you read about some incident that happened in a public place, an airport, a train station, and a week later, they find evidence of it on video, right? And why does it take a week? Because today, so many of those cameras are not smart cameras. They're just storing the big data. And so someone has to go through and look through all of that, 5 hours, if you have 100 cameras in a train station and something happened within an hour, that's 500 hours worth of video. Right? You probably can't get the local police station to have 500 people to look through all of the video. But you can look through all of that in a few seconds, right, on using deep learning. And in fact, you can look through it fast enough so that you can detect things as they're happening and often prevent them. And finally, there's so much great food here in Taiwan, wherever I go, right? But when you think about it, as the population grows and as the amount of usable space we have from farmland decreases, we have to become smarter and smarter on how we grow food. There's a great company, not in Silicon Valley, but in the Central Valley of California, where much of the produce of the US is grown, in the Central Valley. Anyone from the US probably knows the Central Valley is farmland. So a startup based there called Blue River Technologies. They using an NVIDIA GPU that sits out at the end of a tractor. When they go over a field of newly planted any sort of plants, normally what do? 2 weeks after you plant a plant and it starts sprouting, you go through and you spray pesticides, you spray fertilizers. Well, you don't always think about it, but you don't want to eat food always that has used a lot of pesticides. Or what about all the runoff when it rains and those pesticides wash into the river? So what they're doing is they can actually tell the difference between a weed and a lettuce plant or another plant, and they were able to reduce pesticide use by 90%. The challenge is that this gets harder and harder. Just 2 years ago, when Microsoft was able to achieve the first superhuman performance, it took them 7 exaflops, 7 billion trillion calculations to train their network. Today, Google's natural machine translation that can read a web page and translates it takes 105 exaflops to train the network. Now, to many of you, an exaflop may be somewhat meaningless, but if you actually add up the 500 fastest supercomputers in the world, most of which a single one of those would take a larger than this room to run in, that would take you 100 seconds to actually train that Google model, because it's 1 exaflop for all those computers. Now, of course, the problem is even Google doesn't have the 500 fastest computers in the world. So NVIDIA continues to push forward and innovate in technology. Just 2 weeks ago at GTC, we announced the Tesla V100. Again, one of the key features of Tesla and why it can be up to 12 times faster. You say, well, you get a little bit faster because of Moore's law, right? We went from the previous GPU used TSMC's 16 nanometer process, and Volta uses a special NVIDIA-based TSMC process that's 12 nanometer. So we increased the number of transistors. 21 billion transistors on the chip. So it should be a little bit faster, right? But how do we actually get, in this particular case, 12x faster? Now, a tensor, you think, why are many software programs in the AI world named a tensor? Well, a tensor is basically a mathematical object, like a matrix, and that's what gave the name to Google's TensorFlow. Well, we have now a tensor core, a special processor inside the GPU, simply for doing matrix math. And here's how Pascal, our last GPU, did it. If you wanted to multiply two 4x4 matrices, it used the thousands of different cores in a GPU to very quickly multiply that matrix. Now that was pretty fast, but it wasn't fast enough to go from 7 exaflops to 100 exaflops, right, that deep neural network algorithms do. So with the new tensor core, works like this. It can take two 4x4 matrices, multiply them together, and add them to another matrix in one instruction cycle. And we have 120 of those tensor cores on the Volta GPU. And what that lets us do is deliver almost a petaflop, so 1/1000th of an exaflop in the DGX1. And the DGX1 is NVIDIA's version of that system that we actually designed, architected, came up with Quanta 2 years ago, right here at COMPUTEX. This year we also announced a very quiet desk-side version of it. At NVIDIA we have, of course, a big supercomputer that has hundreds of these DGXs in it, right? It's the hardware behind that we use, all of our engineers use. But these are very noisy, right? None of my engineers have one of these in their office, right? And think about how a startup works, right? A startup often has, a room half the size of this stage where they have maybe 10 engineers working. And they all start working in the cloud, right? They're using servers in the cloud. But sometimes they don't want to wait for the cloud. Sometimes they have too much data to move up to the cloud. Now they can have over half or almost half a petaflop, 480 of those tensor flops running in a whisper quiet, water-cooled desk-side workstation. And finally, to make all of that software that NVIDIA is using useful not only on our hardware, but on the cloud and in the cloud, we developed the NVIDIA GPU Cloud. This isn't another competitor, right, to IBM's cloud or to the Amazon cloud or Azure cloud. It's really just the NVIDIA GPU Cloud. Think about it as a software repository. It's where we put all of our software and we optimize it for DGX1 and we optimize it now for the HGX platform. And HGX is nothing more than a blueprint for how to build an optimized GPU-based server. And so with that, I want to invite our next speaker, our partner, Mike Yang from Quanta, to come up and talk a little bit about what they're doing with HGX and with NVIDIA.
Thank you. Thank you. Thank you very much. Good afternoon. I'm Mike Yang. I'm from Quanta QCT, Quanta Cloud Technology Company. I feel honored to share the stage with Mark, and today I would like to share our view of artificial intelligence with you all. The term artificial intelligence was born in the 1950s, and its development has been up and down for half a century. a new contributor in the advancement of AI came with the emergence of machine learning, driven by Moore's law, which states that compute power and storage capacity will be doubled every 2 years. But Moore's law is slowing, and deep learning requires more processing power, which is totally beyond today's processing chip capabilities. So, AI researchers have to turn to the processing capabilities of GPUs. Artificial intelligence has reached its all-time high. As you can see, the research from both from Gartner and IDC. What was once not easy to produce due to the cost and slow compute speeds has now made its way. And the research institutions reporting that computers and algorithms are outperforming humans. Now you can see, I think people will talk about, and even tomorrow's session, you'll see a lot of startups. New startups are popping up every day, claiming to solve personal and business problems. So this is actually proving that AI will be a hot topic in the years to come. So the trend, so you'll see that AI is a trend that we totally cannot miss. Okay. Okay, the demand for accelerating AI has never been greater. Developers, data scientists, and the researchers rely on computational more and more, especially GPUs. In their next advance in image recognition, making transportation safer with self-driving vehicles, providing new intelligent customer experiences, and more. Let me just give you some examples of our current clients. We have a partner that does video discovery services, who actually combines the image recognition and the AI together to recognize categories in video. That is face, image, text, audio, motion, object, and scene, to do better security control and a more targeted marketing advertisement. We also have a few clients in the automotive industry that are planning to adopt similar technologies for autonomous self-driving cars. Even though AI becomes more complex, but we are very confident that more and more GPU will field AI application. And this will come into reality sooner than expected. Okay, so we understand the hassles of current AI implementations. Application owners need to install hardware, OS, AI, HPC, machine learning, specific platforms. It is likely to run into interoperability issues. Not to mention, it takes time and effort to tune the parameters to achieve best performance. With this in mind, QCT is committed to providing a full stack of AI with the following benefits to our customers: adaptive, powerful, and simple. Adaptive. QCT have a variety of hardware form factors, ranging from 1U to U4U and high up to a rack level, to be adaptive to various workloads. So-called 3S1R, server, storage, switch, and rack system. QCT has a track record, a world-leading provider in this particular area. Powerful. QCT is partnering with NVIDIA, optimizes GPU performance, unleashing compute power to fill your application workloads. Simple. QCT also integrates hardware, OS, AI, HPC, machine learning, specific platforms all together to ensure the interoperability. So you will only need to take care of your application and workloads. And the most important thing is QCT can also offer you, based on your specific workloads, we can help you try to fine-tune and achieve the best performance. Okay. So QCT, we help you get up to speed and go to market faster in the emerging AI battlefield. The vision for AI-driven future. We have had a long-term relationship with NVIDIA, as Mark just mentioned, especially 2 years ago. We started up the first AI project with NVIDIA. NVIDIA, we share the same vision for AI-driven future. QCT expanded its server product lineup last year to feature GPUs based on the NVIDIA's Pascal architecture, which is purpose-built to be the engine of computers that learn, see, and simulate. We have worked with NVIDIA to create the Facebook Big Basing server, which is the industry's first NVLink-enabled GPU system. It is without question. With this kind of a track record, we are also very excited about Volta. After its announcement, we do believe it will lead the next wave of advancement in AI and the HPC. QCT is recognized by NVIDIA to be invited in its new HGX partner program, as Mark just mentioned, the HGX partner. QCT and NVIDIA will continue to bring deep learning to everyone, from the cutting-edge research firms to hyperscale data center and telcos and also enterprises. So we're ready for AI. How about you? Good. Okay, this is my last slide. I hope you enjoy the show this week. And thank you all. And thank you, Mark. Thank you, everyone. Thank you. Thank you very much.
And once again, we would like to thank Mark Hamilton from NVIDIA and Mike Young from Quanta Computers for taking time out of their very busy schedule to join us this afternoon. And the next speaker is Peter Pauli Chan. He's the General Manager, Products and Technology, Data Center Sales Group, Intel. Ladies and gentlemen, let us give him a very warm welcome.
Hello. Hi, it's an honor for me to be here today. It's really an honor to be here speaking in front of COMPUTEX. For me personally, it's homecoming. I was born in Taiwan about 40 years ago, and I've been spending time working for Intel for the past 17 years, mostly in the United States as well as in China. So again, it's happy to be here. In the next 40 minutes, I'm going to spend some time to talk about Intel's vision in artificial intelligence, and more importantly, how do we work with customers and partners here in Taiwan to continue to ride with the innovation of AI. So I think, as per some of the earlier speakers talk about, we talk about artificial intelligence, but really it's about data. It's how do you monetize based on data. Artificial intelligence is a technology, it's a technique, but it's how do you realize the value? So one of the examples we like to use is autonomous driving. So Intel have announced a partnership with BMW late last year on a very close partnership to really bring autonomous driving to the market by the year of 2020. And this year, we're going to do some road tests together with BMW on an end-to-end solution. So in that conversation with BMW, we learned quite a lot on exactly what a car company actually needs, right? So if you think about it, today in a car, we're going to have to add a lot of different sensors, radars, high-definition cameras, in all different directions, so the car can actually detect the environment around the car, right? So just in case if something shows up, whether it's a tree, whether it's a person running in front of you, the car will be able to identify the object and make instant decisions on how do we react to that incident. So there's a lot of data. So today, every person like you and me, we probably take a lot of pictures, take a lot of photos, maybe a video. I take a lot of video of my babies. But at most, well, I'm generating about 1 to 1.5 gigabyte of data as a person. That's today's internet, right? Data is made of human. But in the future, in the car examples, it can generate as much as 4,000 gigabytes of data. That's a significant magnitude higher data than what a human can possibly generate. That's only just one car in one day. So imagine, maybe in 5 years, 10 years, when all the cars are ready for autonomous driving, how much data it will generate. How much data do we have to send to the network, to the data center? And it's a cycle, right? The data center need to now digest all the new data through some level of machine learning, deep learning algorithm, and pass that decision back down to the car. So that car can make the right decision on whether it takes a break or make a turn, right? To make sure it makes the best decision for the passenger in the car. So again, to us, this is just one example. There are many different applications, but this is getting us very excited on how possibly the use of artificial intelligence and autonomous driving can transform our lives and surroundings. Click. Okay. A few other examples in industries. I think earlier today that I think we have IBM talk about, DBS talk about financial institute, right? So we look at different industries, right? So on the arrows down below sort of shows where we believe the earliest adoption might be, right? So first is really consumer, right? I think we all hear examples about personal assistant, Apple Siri, Cortana, Echo, right? Consumers like to have the ability to talk to their phone or devices. So consumer is always excited about the next new gadget, right? So that's where we think the first application may happen. Quickly after that, I think folks talk about healthcare, about precision medicine. I'm going to talk more about it, but really, I think all people around us, all wish that there's a better way to find cure to things like cancer, which has been around us for many years, and it's just so feel that it hasn't advanced that much. Can we actually use artificial intelligence to help us to find a cure or advance some of the researches? Finance, we talk about banking, right? We talk about fraud detection, right? How do we make sure all the electronic crime that's happening in the ecosystem is able to be flagged, right? Money laundering, cross-international trading, those are symptoms that actually machine can find. And then the examples goes on and on, right? Smart cities, smart manufacturings, lots of different variety of opportunities. Today, there's no lack of interest. All industries are really thinking ahead about how AI can possibly transform your business. We don't have an answer for everybody yet, but really, AI is really in infancy. People are just realizing that it can really help people solve a problem, independent of which industry you're in. So AI is possible. Why? Why now, right? I think some of us smart engineers have been, jokingly saying, "Oh, this is a computer course we took 20 years ago, 30 years ago. It has been there forever." But all of a sudden, it's hot and sexy again. But really, when we look at it, there's actually multiple reasons. One is really what we talk about, the massive data, right? 5 years, 10 years ago, there's not enough data now on the internet, but now there's plenty of data, right? So the amount of data make it possible. And number two is really compute breakthrough. So that's the era I'm trying to talk about, right? So many of us here in Taiwan has been partners of Intel for the past 20 years. I think especially when we talk about data center, right? I think Mike and the Quanta team has been a great partner for us as well. So we have been going through big generations of changes. 20 years ago, when people talk about servers, and people in the industry call it mainframe. Mainframe is like those big system backstage, and it's mainframe, right? It's sort of an old architecture. But through the past 10 years, the industry has transformed. Over 90% of all the servers or data centers today is powered on Intel x86 architecture based on Xeon. And we have another transformation in the past 3 to 5 years, right? Again, Mike and his business is growing very well with the cloud computing evolution, the rise of the Amazon, the Google, the Microsoft, Baidu, Tencent, Ali, right? About offering flexibility of compute, right? To be able to actually host all the servers virtually and try to allocate resources for people and businesses. Again, this is the second generation of data center transformation. We see AI is actually the third generation, right? It is another new usages that fundamentally drive different usages of data center. Through our internal analytics, we still think AI is actually a very small market today, relatively to the larger data center, right? So in 2016, we estimate about 5 to 7% of the total data center workload, that's all compute in data center, runs about artificial intelligence workload. That's pretty small. But we actually believe it's going to be growing very fast. So we predict in next 3 to 5 years, it's going to grow 12x. So if we do the simple math, right, 5 times 12, that's 70, right? So what does that really mean? So in 3 years, the amount of servers that runs AI workload, it will be 70% of today's total market. That's pretty sizable. That's pretty sizable. And we think that's a great thing for all of us in the industry to capitalize on that growth and really to drive this innovation forward. Investment, right? So again, a lot of this is public information. So we have been on this journey of getting ourselves ready for the new world, right? So definitely in the past 2 years, we made significant acquisitions, a $15 billion acquisition of Altera that give us one of the world's leading FPGA solution. And of course, this year, we have just announced a plan to acquire Mobileye to really give us one of the best sensors solutions for autonomous driving. In addition to that, we're making a lot of different acquisitions to really complete our portfolio, to really attack different part of the ecosystem. But I think the key message here is we're committed. We know Xeon has a great leadership, but when things were at the edge where Xeon or data center may not apply, we look for the best solution and we make sure we integrate them. Our goal is to make sure that we are providing the right ingredient and technology for everything that powers AI going forward. So this is one simple picture, right? Intel has a uniqueness of providing what do we call end-to-end AI. So what is end-to-end? So today, there's really simple way to think about it is, one is a cloud or data center, which 90% plus is powered by Intel Xeon processors. Another end is really the edge, right? The edge could be your PCs, your laptops, your smartphones, which is an example of edge device. But also another edge device is really IoT. I think earlier today, there's another forum talk about different IoT devices, robot and everything, right? And there's everything else in between that make things move faster. So from our portfolio perspective, in the data center, there is this definitely a core offering for machine learning, deep learning on the data center. And then on the edge, we have new product, Movidius. So I don't know if any of you are familiar with this particular company. It's actually a very interesting company. In the past couple of years, drone has been very popular device. And then one of the things, if you ever fly a drone, you're always concerned because it's a really expensive toy, and then it's a high chance that you're going to crash it and then you lost a couple of $1,000s. It's a really expensive toy. So how do you actually get around it, right? So I think right now we're working with the leading drone company, DJI, Chinese name is Dajiang, right, in China, who's the leading drone provider. And we are using a Movidius chip to give the drones computer vision, right? So it enables things like object detection, right? For instance, it's flying through the trees, and then it has a tree in front of it for 10 meters. It actually can sense it and try to slow down or turn around, right? So those are the computer vision capabilities at the edge. So Movidius is a chip that's only 1 watt, really low power, because it's what's needed, right? Because the drone is powered by battery. It can only run 20 minutes, right? If you put a really powerful chip on that drone, the battery life will be 10 minutes, right? Then it really loses the purpose of that drone, right? So for different circumstances, from data center all the way to the edge, we now have a portfolio of products that service a different usage model. And then in between that cloud as well as the edge, we're also investing in new product technologies like memory. I don't know how many of you are in the earlier session with Rob Cook, which is our who talks about our advancement on 3D X-point memory technologies. Intel is also investing very much to make sure that as we advance the compute cycles, we also advance everything around it on memory and storage, so the entire system can also boost its performance, not just a single point. Okay, come back to the car example. We like to talk about car because we do a lot of car stuff. So if you think about the entire system architecture for autonomous driving, right? So there is stuff in the car. So in the car, you can imagine in a Tesla, there's a nice big LCD panel that controls your car. But then behind it is probably what we call a future car will be really a data center on wheels. It has actually a very powerful computer within the car to really drive the control functions, to drive the local decision making, the sensing, data gathering. But then in 3 to 5 years, in the future of the 5G network, it can pass instantaneously a lot of data from the car into the data center, right? And then the data center will do some algorithm analytics and send a decision back down in terms of, what do you want to do? Turn left, turn right, slow down, speed up. And that entire cycle requires end-to-end platform innovation. You can have a very fast car, you can have a very fast data center, but I think a lot of people ask us and say, hey, what about if I have a broken 5G network in west of China? Can I use autonomous driving? Probably it's very dangerous, right? You don't want to go there and then you lose the signal and then you have a dangerous situation, right? So it's really important for us to really look at all the end-to-end deployment and offer that total solution that's proven versus a single point solution. So again, this is more of an internal announcement that if you know Intel typically organize ourselves by product. We have DCG, data center product, PC product under CCG. We have FPGA, right, in separate product group. But I think we realize AI is such a unique usage model. It's really across, just like I said, it's across everything Intel has to offer. So with that, Intel is forming a new sort of AI product organization to really drive the connections across everything we have to offer in order to provide the best solution for the end customer beyond a single point solution. And this is reporting directly to our CEO starting about 2 months ago to really orchestrate that investment for us. So with this new group, right, so a couple of things what we're trying to do. First is AI by design, right? AI is still at its infancy. That's what we say. If you actually follow a lot of the AI articles, you will see different companies saying, hey, one architecture is very good, but Google says, no, they want to do something different, right? Because they feel it's not good enough, right? And we also have the same feeling that in order to do something extremely well, for those of us who study semiconductor, right, you know that there's a general purpose design all the way to application-specific ASIC, right? So really, AI by design is an ASIC design that does nothing but deep learning. That's what we believe is needed for people who need extreme performance. And we have a roadmap on that I'm going to talk about a little bit later. And then it's about how do you apply them? Apply research lab. So this is another great example. I don't know how many of you cares, but sometimes I always amazed. There's a news somewhere that somebody somewhere, whether it's Russia or whoever, found another planet that's thousands of light years away that's similar to Earth. And they say it's possibly there's a life on that planet. Like every year you see some news like that, right? But imagine there's just so many stars out there watching by horoscope, or telescope. But it's at a point that it's beyond a human being capability to really analyze all the massive data out there. Imagine if we can actually enable some algorithm, like AI or machine learning, that can actually help us to mine through all this data out there. Perhaps it gives us a better chance to actually find that potential next Earth or next alien species, right, than a human can do. Lastly, we'll talk about human intelligence, assistance. I think in some places, people just like to have an idea, to have a device or machine or phone talking to you. So again, it's getting some popularity in some places. So this is where we think voice is also a next possible I/O devices, right? Because it's much faster. I don't know how many of you, I'm sure many of you here use Line or WhatsApp, right? But if you ever use WeChat, it's actually very convenient. You can walk through the airport and just press it and just talk, and then you can just pass voices or voice translate to different texts. And next thing you can know, in 2 years, they can also do translations, right, from Chinese to English to whatever, right, automatically for you. It's coming. It's coming. So from an Intel portfolio perspective, this is one busy page, but it articulates how complex AI is, right? So again, I want to just share with you here, because I know many of you here are either hardware programmers or software programmers. You're working on different pieces of the ecosystem. So from an Intel perspective, definitely we have different silicon offering down below, right? You see different logos, familiar faces, right? From Xeon to Core to FPGA. One layer above it, we're also doing a lot of software investment, right? We want to make sure it's easy, right, for people. Because one of the questions we got is, you have so many offerings, so how do I know which one to write my software on, right? So it's our job to make it easy for the software ecosystem. So we're providing a set of libraries that exposes our hardware capabilities. On top of that, in the middle part, is really the public domain, right? So if today, AI is still at the very beginning. So there's many different public framework, right? Really sponsored by different CSPs. TensorFlow, right, from Google, Caffe and Caffe 2, endorsed by Facebook, MXNet, Amazon, right? The list goes on and on. Because right now, there's really no single standard. And our job is to make sure that, hey, whichever framework you're using, we want to make sure that it runs very well with the Intel architecture and Intel hardware. Okay, so we are investing the thousands of software engineers to make that easy for the ecosystem. On top of that, it's about some more additional SDKs and deep learning studio, because what we really want to realize with the ecosystem is really on the top, right? It's really, what solution can we implement? Whether it's autonomous driving or the smart city, is it precision medicine, right? Really, that is the solution people cares about. They don't care about what's down below. So we have to invest to make sure it's easy for everybody. So let me, just for my interest, right? I know there are some of you are startup here, right? So how many of you are coming from a software company or a software developer company or AI software companies in the audience? Anyone? Raise your hand. A little bit here. Okay. So I want to point you to the website we have, right? Well, softwareintel.com AI Academy. Again, it's our intent to make sure most of our software tools is available to the software ecosystem. Whether you're a startup or you're a university student, you're university professors, you're just interested on what's going on with AI, we have lots of assets in this website for you to have contents for. So please do take advantage of this. We want to make sure that we make this available to you. And again, there's no cost or no charge, but everything is here to make sure you understand what do we have to offer. I think interestingly, I saw Jeff, show this slide as well. Partnership on AI. It's an open society. Again, the purpose here is to make sure there's an open standard for AI. I know many of us watch a lot of movies. In movies, the robot do bad things, right? So a lot of people are concerned about how AI may do bad things to the world. But I think what we really like to think is, I would like to position a little bit differently than Jeff, right? I think it's really up on us, right? It's really for all of us in this room, whether you work on hardware or software, you're part of this leading IT world, right? And it's really up on us to really focusing on guide AI to the positive development to do good things for the society, right? So we are the first chip company to join the society because we believe it's about shaping how this thing is going. Today, AI is like a 3-year-old baby. It's about how we teach it and how do we handheld it to the right direction, the way we want it. Okay, so this one a little bit hard to read, but I was trying to get Alibaba here, but unfortunately the guest could not get a visa to Taiwan on time, so I have to speak for him. So in China, what we have done, collaborate with Alibaba, is that Ali has hosted cloud services called AliYun, right? And then together with some local health care and hospital collaboration, they're trying to see how can we guide AI for positive usage. So this particular case, they have identified, hey, lung cancer is really a big problem, right, for a lot of us in Asia, right, because of bad air, because of people smoking. And it happened to be, it's one of the usage that AI can actually help. Because if you look at X-ray or CT scan, it's basically a really hard to read picture, right? Today, even the best doctors have, say, 70% or 75% accuracy of actually reading that CT scan. But the machines can probably do a much better job at analyzing all the data. So what this contest is all about is Ali, together with the local medical authorities, is able to get access to a set of X-ray or CT scan images, and then it's opening for the local students to really write an algorithm and see which algorithm can come back with the best tool to help the doctors to analyze those CT scans and X-rays. My understanding is the contest is not limited to China only, so it's open to anybody who is interested. So if there's any one of you who's interested and think you can try to take advantage of this asset and do something great for the Medicare, please go ahead and check this out. It's called 天池大赛. Again, Intel is a proud partner as we provide our Xeon and Xeon platform sponsorship for this contest. Again, this is one example on how we are committed to really use AI and guide it towards positive usage. Okay. Sorry, I have to come back to Intel products after 30 minutes. Eventually, we'll come back to Intel products. So let me try to explain things in a little bit simpler way. In the data center space, today, there's plenty of Xeon processors all around the world. It powers 90% plus all the servers out there, whether you're in a cloud or on-premise. It's the most widely deployed architecture. Xeon Phi is our high-performance, highly parallel workload processors. I'm going to talk a little bit about the uniqueness in the next page. But on the crest is what we call really the best-in-class deep learning ASIC, right? It does nothing but just deep learning, right? And then people are always ask the question and say, hey, we read about FPGA. By definition, FPGA can do a lot of different things. So what can you use it for? We think FPGA is actually very unique as it helps on inferencing data. I think earlier, there was some example talk about smart cities. So today, we actually have customers today looking at cameras, right? Even city of Taipei, right? There's plenty of video cameras in every street corners, right? Today is all analog, but in a couple of years, it'll become all digital, right? So there's many things you can do with it for a public safety, per instance, right? If there's a crime that's happening, and today, what happened is you have to report a crime, you call the police have to go back and try to figure out which camera potentially have the shot of the possible criminal and sort through it. After 5 hours, potentially find, hey, this is a suspect, potential, right? And then the guy may be gone already because it's 5 hours past, okay? But imagine in the future, all the camera becomes smart and digital, right? And then if this is a suspect, police already have profiled on, and then if we already know, hey, this is Mr. So-and-so and who's in suspicious activity, we can instantly actually download those algorithms down to all the cameras, right? And say, hey, I want to find Peter in city of Taipei. So instantaneously, the algorithm downloads all the cameras, and the next camera will take a picture of Peter, automatically send a signal back. He's in, Shimao, right? TICC, giving a speech, right? So you don't have to actually go after the fact, but because it's instantaneous, right? Those are capabilities, actually, it's going to happen very, very soon. And those high bandwidth, high volume inferencing, we have customers telling us FPGA is great for it because you can expand it. Depending on how many video streams you want to support, you just keep adding FPGA card. It's great for high volume inferencing, right? This is an example of what people are using it for. So coming back to Xeon, right? So lots of words here, but really it's about flexibility and proven, right? So today, customers like Google, Amazon, Ali, Tencent, everybody use thousands and thousands of Xeon because Xeon can do a lot of different things. It can run your email, it can run your database, it runs your customer relationship management system. Oh, by the way, you can use it for machine learning too, right? So I don't know about you, but I remember about 7 years ago when I was doing some Facebook, it's probably the first time Facebook was telling me, hey, Peter, here's your friend's picture, Michael. Is he Michael? Click yes or no. And it was, first time I was surprised. Oh, he actually knows my friend's Michael's photo somehow magically. But remember, that's 7 years ago. I don't know how many years ago you remember that was. But 7 years ago, there's no deep learning, right? 7 years ago, there's not word called AI, but Facebook already did it. What did they do it on? They did it on Xeon, right? Because Xeon can do the same workload with no specific architecture. You don't need to have deep learning, right? So for us, what we're really thinking is, for majority of data center, Xeon is the most flexible platform. For many customers today already buying lots of Xeon, right? Great. Let's just make sure that you're ready to use the Intel tools and actually run some deep learning or machine learning workloads on Xeon, right? No problem. And it's proven and ready. It's shipping in high volume to everybody. Thanks to, again, many of our customers and partners in Taiwan, the different ODMs, different OEMs, we are shipping plenty of Xeons worldwide. Nice meal. Let me talk a little bit about next generation Xeon Phi platform. It's coming soon. It's actually in the next couple of months, where we're going to ready to give some first samples, right, to our partners here in Taiwan as well. It's really actually our first processor that's actually repurposed for deep learning workload, right? So it has more than 70 cores, but what we did is make sure it's optimized for single precision operation, which is critical for deep learning. We believe with its extended memory capacity, it'll be a very, very good platform for running deep learning, right? So again, we are very confident that in the next couple of months, we'll be partnered with our partners here to bring this to market and make it a competitive platform in the market space. Nirvana, again, this is what we call deep learning by design, right? So if you remember, Xeon is like a Swiss Army knife. You can do everything with it, right? But this is like very specific. It's nothing but deep learning, and it does it very well, right? So if you think about it, we don't actually think this is something for everybody. We don't think every company in the world want to buy a special tool like this, right? But we do believe there are some people who are very invested and say, hey, I just want the best for the best. I do nothing but deep learning. Just give me the best product. And this is really our recommendation. It's really our Crest family. It has very specific architecture. It's not a general purpose CPU. It has high bandwidth memory of 32 gigabyte packaged within the chip itself. And what's also important is bidirectional high bandwidth links. For some of you who are a little bit familiar with PC architecture, today many of the things connected in a PC using a PCI bus, right? That actually means it doesn't really matter how fast your thing on the car runs, your bandwidth is limited by PCIe bus, right? But with this architecture, it sort of skip that concern because we're not using PCI bus anymore. We have specific bidirectional high bandwidth links connecting all the Crest silicons together, right? So it doesn't have any bottlenecks on your highways. So again, we are not ready to announce customers here, but hopefully in the next 6 months, we'll be able to say more about who we're working with on the Crest family and be able to make next level announcements. Nirvana platform. So I think earlier we talked about it, like different approaches is all lead to the same path. Today there are many enterprise trying to figure out what is deep learning, how can I use it for my company, what problem can I solve? Because not everybody is very familiar with all the hardware and software required to really take advantage of AI. So we also have a cloud service offering that we are curating within Intel. Again, we're not trying to make a business out of it, but really it's about proving ourselves, right? We realize by just selling the silicon itself is not enough because people want the entire full solution services. So this is how we bundle our own software with our own hardware as a total cloud solution. And then we're working with some lead customers worldwide, whether you're in a bank or healthcare, to really test drive the whole thing to make sure that you actually solve a real problem in the real life. So again, this is something we now have capability of and have some initial engagements on, and we believe it's the right way for us to understand the market and be able to create better products. Okay, to sum it up, I know I talked a lot of different things, but really it's a couple of things, right? Key takeaways. AI is not just a technology. At the end, it's just a technique to help business to monetize your data. The data can be different sort of data, but AI is just a technique to monetize on it. And our approach is really threefold, right? Today, we are well positioned at scale. There are thousands and thousands of Intel Xeon data centers on the cloud or in enterprises today. So we're already there. And we're already helping many enterprises take advantage of your current data centers. But going forward, we're really taking two approaches. One is end-to-end, right? When we talk about AI, I think earlier there was talking about some robots, right? Robots is just a form factor, but there could be so many different things within a robot, right? And a robot sometimes can connect to the cloud, or it doesn't have to connect to the cloud. It can just run itself, right? And today, many of the public doesn't look at AI the same way, right? Just think about anything that moves on its own is AI, which is very different from the data center, deep learning, very specific, narrow definition of AI. But for us, we think it's actually all important, right? Because to the public, it's all about realizing your full solution from data center all the way to the edge. For instance, like an autonomous driving example. And we believe we are uniquely positioned to actually bring that to the market all the way from cloud to the edge. And lastly, AI by design. Again, AI has different elements. But if we talk about just deep learning alone, we believe by actually creating a dedicated architecture just for AI, will give its best performance in terms of for deep learning. And that's what we're signed up to do. And we're committed down this path, and we like to really work with the ecosystem, partners here in Taiwan, to really bring many of these new product, hardware and software solutions into the market so we can grow together and ride a wave of AI. Okay, so that concludes my speech. Thank you very much.
And thank you very much for joining us this afternoon, Peter. And the last speaker this afternoon will be Zhihan You. He's the CEO and co-founder of Appier. Appier is a technology company that makes it easy for businesses to use artificial intelligence to grow and succeed in a cross-screen world. Under Yo's leadership, Appier has grown from a 5-person startup to become a rapidly growing company with employees throughout Asia. So without further ado, ladies and gentlemen, please help me welcome Zhihan You on stage.
Hello everyone, thank you for staying until the last section. Today I would like to talk about a little bit about our perspective in artificial intelligence. In particular, how we put AI into actions. My name is Zhihan, and if you have any questions, feel free to interrupt me. Just a little bit of introduction of what is Appier. What we do is we help customers, our enterprises, to win and succeed in cross-screen world. Currently, users are behind multiple screens. We help them to analyze and predict and act on these multi-screen worlds. Later, I will explain a little bit more in detail. Just a little bit of background of myself. Before this company, I have been working in the field of artificial intelligence for more than 15 years. Actually, when I was 20, I started building my first AI application. That was face recognition. I was totally amazed. It was so cool. Computer can think and also recognize faces. And from that on, I started building a lot of different AI applications, in particular in robotics. So I've done a robotic dog, use AI to let the dog learn to balance, stand, and also climb, and also self-driving car back in 2004, and also some decentralized artificial intelligence. Because when the computation power was not as strong as nowadays, a lot of time, AI cannot think like human, like centralized, think about everything. So we also thought about how to use decentralized, just like how we scale organizations in the decentralized way to make every individual component to be able to think and then assemble back. So I've done a lot of some transformer robots and also proved the theory of a decentralized artificial intelligence. And fortunate to work with one master in centralized AI and also one decentralized artificial intelligence. Just as the moderator just introduced, we start from a 5-person living room startup 5 years ago. And after a lot of pivots, some change of directions, and gradually we grow into a more mature company. And earlier this year, we were elected as one of the top 50 AI companies in the world that revolutionized artificial intelligence space. In particular, if you look at geographically, we are one of the longest startups in Asia got elected to the list. There were only 4 startups from Asia in this top 50 list. But imagine we have half of the population in the world, but only 4 startups. So there are a lot of space, a lot of opportunity in Asia in artificial intelligence space. As well, we were elected as AI 100 and also top 4 marketing startup in AI in the world. Currently, we are now operating in 12 cities in 11 countries, and with a headquarters in Taipei, and serve with more than 500 customers, and proudly to help them to solve the problem and also to help them to interact with the customers by using artificial intelligence. Now, I want to talk a little bit about why AI is everywhere and why it is now to do artificial intelligence. It is predict that, let's look at the economic figure first. It is predict that from 2017 to 2021, annual growth rate of the compound annual growth rate of artificial intelligence will be more than 50%. This is probably one of the highest growth rate field since internet, mobile, then AI. And you will actually impact, it is predict, you will impact $50 trillion of a business value by 2025. So it's actually a very big field. And there are a lot of space to have innovations. I think earlier, Chairman Huang actually talked about a lot of company in CB inside this. There are thousands of startups in AI, and actually every day there are new AI company born on a daily basis. And amongst these 100 artificial intelligence startups, majority of them have venture funding back. And you also have seen a lot of consolidation, acquisition in AI space, but you will also see some of the emerging leaders in the public market in a few years from the AI artificial intelligence field. But fundamentally, what is artificial intelligence? I would just want to use very, very simple analogy to help everyone to understand the process. To me, it's just like making breads or making cake. Data is ingredient. The ingredient, the input of assistance. Then you have an automatic food processor. That will make to take those ingredients and make into breads or cakes. But very importantly, you need to have the bread or cake experts to tell that this is a good bread, this is a bad cakes. It's just like in artificial intelligence, you need to have label data. Data and label data are different. Especially the wrongly labeled data is worse than no data. So you need to have expert label data to make a machine learn well. It's just like you need to have a judge to tell what bread or what cake is really good, to make this food processor learn to make the best ever bread or cake. Then, what does data scientists do? It's kind of a cool job, right? Everybody said data scientists can, it's the hardest job of the year. A lot of people want to learn data science, machine learning, deep learning in order to get this job. But what do? They design food processors. What is a good design of a food processor? For those who can actually make a good cake fast. Also, make it the best ever delicious cake. So that's the beauty of a data scientist. If they can design a food processor that can really make good cake, then it's actually a good data scientist. So hopefully this analogy can help you to understand a little bit about machine learning and what do those cool data scientists do. I just want to tell a little bit my feeling, personal feeling about this in recent years, because our company started around 2012, so it's been actually still 3 periods of time. I feel like 2 periods of time, and also there will be another period of time. Just my personal feeling. I think around 2011, 2015, there are a lot of promising results from artificial intelligence, in particular, the deep learning field. I think in the past, computer vision has been not able to break through for a while. But since the birth and the utilization of deep learning in speech, vision, and other fields, actually there's a lot of breakthrough. And some of the superhuman intelligence actually start being born. It's super exciting. I think 2011, 2015, you start seeing some work get a very promising breakthrough and result. I think currently we are now in the second phase of this AI period, become very competitive. A lot of people want to do artificial intelligence. Big companies, small companies, we all want to provide some solutions. Using those solutions, building on the foundation of the promising result we got from 2010 to 2015, actually even further in the back. A lot of research energy and the previous R&D developments result got unleashed. So a lot of solutions got built between 2016 and 2020. And from 2020 onward, AI is everywhere. I think some leader will emerge, and people will start getting used to use artificial intelligence applications. Just a little bit my feeling about how this 15 years of AI period will look like. But if you look back, AI is actually not a new field. It's not actually, it was not born in 2011. I started building, I'm kind of I started building face recognition roughly in 1999, self-driving car 2004. Actually, it has a long history. So you look at that, some of the great scientific breakthrough. For example, IBM Deep Blue defeat chess master. And then we also have AlphaGo recently. And we have even back in 1950, we had Alan Turing, if you have seen the movie or Imitation Game, built the first AI machine to decode. So what's the reason that AI actually was born more than 60 years ago, but only now become a popular word? It's actually, we have twice major AI winter, and the reason is people in AI field overpromised and underdeliver. Twice, major setback. And nobody want to fund AI project except some military funding. That's why you see me build some dogs and then also some automated robotics. Because back then, only the Department of Military Defense will fund AI project. So, but it's actually a great period of time. You can concentrate and focus. Just think about a problem, don't think about money. It's the best period of time for innovation. But like inside a company, if you overpromise and underdeliver for 2 times, you're probably out of the game. But AI is lucky. It got 3rd chance. But I don't think it will get 4th chance. 3rd chance is very important. We need to make it work this time. But I think, based on my theory, I think this time will work. What's the reason? I think number 1, more data, especially more label data. Because internet and mobile make the label data, how we get the mobile data, label data, easier through the user behavior. So there are a lot of label data generated on a daily basis. Second, thanks for the colleagues in NVIDIA, or Intel, and also recently Google. Computation actually play a very important role in this innovation process. Because when I was a student, I still remember I designed an algorithm. Roughly, every day my daily routine is very similar. I try to design an algorithm before 10 o'clock, 11 o'clock, sometimes 12 o'clock, before I go to sleep. And then I have it run for 8 hours. And when I get up in the morning and I go to a lab and check my results. And if there's a bug, then one day is gone. So I keep iterating like this. Every day I try to do this innovation. And then even a very simple algorithm requires hours of time to train. But nowadays, if I look at our engineers, when they train a very complicated algorithms, it only takes minutes. So then it's no excuse. In the past, the best excuse for machine learning students is, oh, my algorithm is still running. Please wait for a result. Or you ask the employee, in doing machine learning, the machine is still running. Wait for a result. But there's no excuse anymore. So the limitation of the innovation in the past was machine power. But now it's actually human creativity. So machine can cope with, can be very fast. But actually, on the other hand, I also see my colleagues design more and more complicated model. So as we have a reason to buy more GPU cards. And algorithms getting more complicated and sophisticated. And such that we can exploit the power of those GPU and good computational resources. And last, actually, I think the last is the most important thing. When I start a machine learning field, it's like we have some idea, then we publish a result and wait for half a year, then we present it. But nowadays, a lot of people is like waiting on archives for the newest results. In particularly, there's very standardized benchmark, very standardized development platform, so people can run your code. People not only share the idea immediately, like they should share on Facebook, they put on archive immediately, and at the same time, they also put on a source code so you can run it. So the innovation speed is actually much faster. The community mindset has much higher momentum than past. I still remember when I was in the class of when I was in 2004 when I took machine learning class back at Stanford. Roughly 70 students took the class. But nowadays, I heard 700, not counting the online ones. 700. There are only probably 2,000 students enrolled in one class. You count in all the humanity major, biology major, everyone is flocked to the machine learning and artificial intelligence class. So the momentum and mindset is actually very healthy. So it's make it possible that we may be able to see there's no third AI winter. This time we'll probably make it right. And so that's also why people predict that AI will be such a big field in the coming years. I want to a little bit recap a little bit and also get used to what kind of algorithm, what have machine learning or AI algorithm evolved over time. It might feel funny for the process, but this is just an evolution process. It's good to understand why people think this and that from the past. First, I think before 1980, sorry, my bad. So people will just write down the logic, and they think that the logic is right, and then become some rules, and that become AI. And around 1980 to 1999, expert system become popular. It's just a kind of modification from the previous versions, but instead, writing my own logic, I ask a few experts, and to see where the common logic is, and write down those rules, and that become a so-called artificial intelligence system. Around 1995, machine learning comes. You no longer need to write down all the rules. You just give factors into the rules, what factor will lead to what, and let the machine to figure out the relationship between factors. That was the approach around 1995, the machine learning standard traditional approach. Buzzword about deep learning. People talk about deep learning every day. What is different from traditional machine learning? It basically not only learn factor, but also learn the relationship between factors. In machine learning, we call features. Features, basically, you can think as factors or variables. Not only learn those factors, there's no human engineering required in the system. Then the machine to learn those factors and also the relationship between those factors. But also it comes with a cost. You generally, but this is you can have a lot of hundreds of example that is this curve is not right. I'm not responsible for this curve, but generally, when you have more data, deep learning works because you not only need to learn the causality between the factors, but also need to learn what are the factors. But when you only have a smaller data set, sometimes traditional machine learning approach still work. So when you get some data set, don't be rushed. Try to think about whether you have enough data to be put into very complicated, a big model for learning both factors and causality between factors. The insight revolution in enterprise. I want to share some of our thoughts about enterprise artificial intelligence. You might have heard about using AI to fight cancers, to prevent crimes, or enacting laws, or reading some of the law documents. It's actually getting there. But actually, if you look at inside the company nowadays, it's actually even closer to be the environment to do artificial intelligence. For example, in marketing, finding the right segment of user that will like your product. That can be solved by artificial intelligence nowadays. Finance, trading, because people trade too slowly. And sometimes you cannot take into consideration of so many different factors. But machine sometimes can trade and beat human being. At least it can overcome the time and also space constraints. So you cannot trade the whole day long, and you cannot trade like within very small small period of time. Also sales. Some of the companies actually developing sales tool that to find you customers and also look like customers. For example, you close some deals that the company look like ABC, but you will find another company called Alpha, Beta, Gamma look very similar to ABC automatically. You don't need a sales assistant to help you to find it. You don't need even to open the phone book. And also, some companies trying to innovate in such a way that how the salesperson reply emails to increase your close rate or increase your email open rate. But why enterprise or company is the best place to adopt artificial intelligence? We can use AI to learn from data, and more importantly, can discover insight from data. Can even deeper analyze the data, predict the outcome. More importantly, we can let it act automatically, repeatedly, on behalf of us. At some time, we want to make decisions. We can see some initial filter decisions from machines before we make the final decisions. So that guarantees you some sort of improved decision or the lower bound that decision quality you will have. And then you can always optimize your decision quality if you want to fine-tune and have more factors in. There are two major factors that why I think, from our point of view, enterprise is a very great place to apply AI. Comparing with living room, which is the end user space, in office space, usually there's more clear, identifiable, measurable goals, because every company needs some revenue. Every company needs some profits. Every company has some expense. And from those factors, you break down. Usually companies' objective and goal can be much more clearly written or much more clearly identified comparing with some entertainment or like end user space. Because machine learning is, you will look at this, artificial intelligence generally is trying to optimize certain goal. If the goal is more clear, it can easier to achieve. Some of more vague goal, like leadership, imaginations, or some of the creativity or flexibility, that kind of thing, machine cannot do that well. You can ask the AI, please be more flexible. And what does that mean? It cannot be measured. If you can be 10% more flexible, then you can probably try to do it. So more measurable will be helpful. And the second, thanks God for the last generation buzzword called big data. A lot of companies start collecting a lot of data. The data become bigger and bigger and bigger. Not sure if they put it in use, but actually a lot of companies store a lot of data. So that becomes good resources if we can have good labels on those data for machine learning. So I think generally, if you compare consumers, the living room space, in office space, there are two very important factors that make it very promising to apply machine learning or artificial intelligence. I want to also share one concept. In the past, a good leader are those who can use human intelligence really well. I think the future leader, you need to coordinate both human intelligence and also artificial intelligence. Because when you make decisions, for example, you want to design a product, you want to design the best package for this product, you can have a machine to run some simulations and to let you pick the best from those options. And then your colleagues can assist to do other jobs. So you need to coordinate both AI provide solution and also human solutions. So at the same time, I think in the workspace will be human intelligence plus AI intelligence. And good leader is not only those who can coordinate human resource well, but also artificial intelligence resource well. I think that's a very important perspective for the future of leaderships. Putting AI into action, just want to use some of example that what we come inside app here, what we do as an example of how we put AI into actions. Fundamentally, what we feel as a core, we are artificial intelligence as a service company. It is a new word, but what does that mean? What we actually do, because we actually identify and recognize the user's own devices across different screens. And with this data, then we can provide marketing intelligence in which we help our customers to reach their customer much more precisely. For example, we know this person always, when she use mobile phone on the move, is in a commute mode. Then we can give this person more like commute or taxi coupon. If we find this person on a laptop and static, most likely it will work. And give very good contextual information that this person is working and give them some a professional type of messages. And also, sometimes you feel advertisement is so annoying because you see on one device, it is one product. And you also see on the other device, it's also the same product. You are not interested in that product, but why it keeps showing on all your multi-screen? Because it cannot recognize it belongs to the same user. But if you see it on one device a few times, clearly show that you don't have interest and stop showing on the others. So that's how we do our marketing intelligence by leverage cross-screen intelligence. On the other hand, we also have an AI as a service by leveraging this cross-screen data. What we do is we help, because nowadays, inside company, there are a few big challenges. One is data is actually scattered around different departments. And different departments have a different data with different type of IDs. For example, marketing department probably have data about apps. CRM department has about their customer behavior with email association. And sometimes the IT department have some web data. But they are all in different formats with different ID associations. We help the company to link them together so you have a complete view about the data. And secondly, it's very hard for company nowadays to find data engineer to clean up those data. We help them to automate this process. Just plug into our engines, automatically we do the cleanup. Then, it's even harder to hire a machine learning engineer. And sometimes they don't even talk human language. They can only talk about programming language. But how we communicate? And we make it very easy interface that you can just drag and drop. You will know how to do Lego, then you know how to do predictions. And we also do immediate outputs. It's from very simple platform that from audience prediction, then you can get inside. In particular, you can upload your file, first step. Second, use like Lego type of assembly, then you can do prediction very easily. Third, you can put it in action, also to your own system or to appear Facebook or other Google Line networks very quickly. So you can be a machine learning hero without knowing machine learning. That's the goal. And there's just a couple of applications you can do with our platform easily. And instead of building a system for months, you can actually use this system within 1 minute to improve the user subscriptions, expand your audience, boost revenue, etc. And what's next for artificial intelligence? I think the number of data from 2013 to 2020 will be tenfold. As previously described, it's just like you are running a bakery and your ingredients keep increasing every day. So you must know how to process those ingredients in order to make a good cake. So artificial intelligence is a way that for you to make into good cake. In particular, I would suggest try to organize your data and with expert labels, because the value is drastically different. Try to have your process in your data pipeline at some point, have a clear label of the data that in the future or even now, you can do much better analysis. With a tenfold increase of the digital data, it's very important from now on to look at the data pipeline and also start be in touch with AI and start the processing of to learn how to process into to make a cake. Oops, oh, sorry. And there's a few trends from a perspective for artificial intelligence. One, AI will be a new UI. We have seen series of face recognitions or emotion recognitions, a lot of recognition systems. I think that will be a new interface. And it was also tremendous help for a lot of computational platform. Because in the past, some of the elder people, they might not know how to type, but now they can talk to a computer. They can use natural language interface or natural gesture interface to interact with computer. So computer adoption will be increased. So AI as a new user interface is one trend. Second, AI is a core technology. For example, nowadays, in e-commerce, all the selling, a lot of times through recommendation engines. From a search and also the item you might also like. A lot of sales actually driven by that. It will be the core technology for selling, for doing marketing, and other things. The last will be important business consultants. When you make the business decisions, if there's some artificial intelligence system can filter out and also give you some of the options and also decision suggestion at first. So you can just pick from those options. Then your decision quality will actually be improved by just filter out those mistakes, possible mistakes. So it will be a very powerful decision and also business consultant for you. At least to filter out, because we are living in a very noisy world, and filter out those impossible and also those errors, and also improve the work efficiency in the workspace. Oh, sorry. And talking about Taiwan, where we are now, I think I always feel like Taiwan is a startup. A startup company, when you face a big company, what do? You be focused and also specialize on one thing. As Taiwan, as a country, when facing a lot of a much bigger country, we also need to specialize in one thing. And if our governments and our industry, if we can build a healthy system with talent and also a good support, and then this is the job for entrepreneur to find the best value propositions, best solution and focus in certain fields that we have an obvious advantage. Then I think AI will be one of the, Taiwan usually say, small but beauty. We can become a small but beauty AI country. And that's pretty much it. Thank you so much for your listening.
Thank you very much for joining us this afternoon, Mr. Yo. And ladies and gentlemen, with that, we conclude the program this afternoon. 我们今天下午的议程到这边就圆满的落幕了。And we would like to remind you that there will be another forum, which is another highlight of this year's CPX forum on innovations and startups tomorrow. It will begin at 9:30 in the morning and the doors will open at 9 o'clock. 再次感谢各位贵宾今天的莅临，今天的人工智慧论坛到此就圆满落幕了。我们再次的提醒您，明天早上有 Innovations and Startups， 另外一个论坛将是9点半开始，9点开放入场。敬祝各位贵宾参展愉快。